Welcome to the next segment of High School Geometry with Netz and Weichel. I'm Mrs. Netz,
And I'm Mrs. Weichel.
and today we are going to be covering 2.1 congruence. The learning target for today is, by the end of the lesson, I will be able to explain one of the most important applications of geometry, proving shapes and figures are congruent. Another word for congruent is equal to or the same. Why are we learning this? Well, we need to understand congruency of polygons to allow us for better understanding of congruence and similarity of triangles. How will you know it? I'll know I have mastered it when I can show the sides and angles of one polygon have a 1-to-1 ratio to another polygon.
All right, let's go ahead and get started. So one of your first vocabulary words we're going to go over in this class is congruence. If segment AB and segment CD are being compared and they are both 5 centimeters in length, then it can be said that AB is congruent to CD. So go ahead and fill in that word. So we're dealing with two things here. We're dealing with segment AB and segment CD. So one thing to note is that they are both segments, so they are both the same shape. They are also both 5 centimeters in length, which means they both have the same size. So go ahead and fill that blank in as well. It's when two figures or objects have the same size and are the same shape. You are going to see the symbol a lot. It's right here. Please make sure you have that. It is an equal sign with a little squiggly line over the top of it. That is the symbol for congruence. When we are talking about congruence, you are saying that you have two same shapes, same size.
Mrs. Weichel, do you know where the congruence symbol comes from?
Where does it come from?
Well, the squiggly line we use a lot with things that are similar, and the equal sign meaning they are the same. So it's a combination of similar and equal.
Very interesting, Mrs. Netz.
Go ahead, share.
Okay. So a congruence statement. You will hear us all the time say, write a congruence statement. What we mean by that is not write a full sentence. We want you to write a mathematical statement dealing with two objects that are congruent. So the congruence statement for the example we did above is that segment AB is congruent to segment CD. It would be written just as it is right here in this circle. Right here, you can see. AB is congruent to segment CD. And you would say that as segment AB is congruent to segment CD. It's taking a sentence and rewriting it using just mathematical symbols and numbers. An important note, when writing a congruence statement, keep this important note in mind. You must look at points that are in the same place when you're comparing shapes. So if you're looking at two triangles, you're going to look at points in the two triangles that are in the same place. If you're looking at two rectangles, you have to look at the different vertices in the two, and you're going to compare points that are in the same place as one another.
Or sort of like if you were to compare, for congruence, identical twins. You would compare their right hand to their right hand. You would not compare their right hand to their left hand.
Okay, so we're actually just going to go through some examples looking at whether or not we have two congruent figures. So are the following figures congruent? If yes, write a congruent statement. So the first thing you have to check off is, are they the same shape? Are we dealing with two objects that are the same? We are dealing with segment AZ and segment EH. So we are dealing with two segments that are the same. We have segment AZ and segment EH. The next piece is, are they the same size? We can see that the distance from A to Z is given as 1.5, and the distance from E to H is also 1.5. So therefore, they are the same shape, both segments, and they are the same size, both 1.5 inches. So we can say that segment AZ is congruent to segment EH. And there's my congruency statement.
Perfect. Let's go ahead
Next, we're going to look at some angles.
All right, so we have two angles, and these two angles are obviously not the same size. We can tell just by looking at them.
So while they're the same shape, They are not the same size.
What I would like to encourage all of you to do, however, is to take out your protractor and to give a measurement of these two angles. So if you would, go ahead and pause your video, go grab your protractor, measure both of these angles, and then check to see if your measurements match ours.
Okay, so here's my protractor. If I look at this, I can see that this is right about, I'm getting about 115 degrees for my angle A.
When I measured mine, I got 125. So if you're getting somewhere in that same area, we're going to go ahead and call that good because you're going on a paper copy and we're going on our electronic copy.
I am getting 50 degrees for angle B.
Oh, I got 50 degrees for angle B as well.
So to be congruent, you have to have the same size and the same shape. As we said, we had the same shape, we had two angles, but they are definitely not the same size. One is an obtuse angle at 115 and one is an acute angle at 50 degrees. So we would not be able to write a congruency statement.
If on yours you are having difficulty measuring the angles with your protractor, remember that you can always extend the rays to be long enough so that way you can use your protractor. So
you need to extend this out like that. So what she means is if you're looking at it with your protractor and you have something like this, which I suspect many of you will, you can see that my angle's ending here, yet the degrees are way up here. So you may need to extend your angle, the ray, out longer so that it intersects the degree part of your protractor. Okay, let's go ahead and go to the last diagram on your guided notes on this side. Are the following figures congruent? If yes, write a congruency statement. So we have two circles here. The center of the circle on the left is C, and the center of the circle on the right is D. If I am looking at just circle C, what would we say CD is?
CD is looking to me, it is about halfway across the circle, or maybe even exactly halfway, so the radius.
And then if I am looking at circle D, we would say that CD is also a radius. So therefore, if I'm dealing with two circles, so they have the same shape, check. Are they the same size? There's no numbers here. We can't measure a circle, but we do know that they are sharing the same radius.
Well, if they have the same radius, that means they both have the same diameter. And if they both have the same diameter, that means they both have the same distance across the center of the circle. So they have to be the same size.
So there's the symbol for a circle. Circle C would be congruent to circle D because they have the same length radii for both.
Perfect. Let's go ahead and turn the page.
These two triangles are congruent. So you're being told that you have two triangles that are exactly the same size. What congruent statement can be made knowing this? So if I'm given, which I am, that the two triangles are congruent, that means you could write a congruency statement that the two triangles are identical. If you remember back to the beginning of the lesson, I talked about how you have to talk about points that are in the same place of the two triangles. So if you look at this, we have point A, which is our right angle in this triangle. Point N is going to be the same point in my other triangle.
If you start off when naming congruent parts of polygons, if you'll start off by naming the two polygons, you will find that using the names of those polygons will help you to write all your congruency statements. So we're going to go ahead and just say that that is triangle ABL. And then what we need to do is we need to find the corresponding parts on the other triangle. Well, we've already decided that A is a right angle, so on the other triangle, the corresponding angle would be N.
B is between this 8 and 13 length sides. So if you go over here to look for the same point, you're seeing that between the 8 and the 13 here is S. So where B is, we would say S. And then lastly, L was written last based on how Miss Netz named us, ABL. L is between the 12 and the 13, and so is O. So we can say that triangle ABL is congruent to triangle NSO. Now, because we know those, we can also say something about all of the side lengths and the angle measurements. If these two triangles are congruent, it means everything about them is the same size.
Now you can use the naming of the triangles. I actually prefer using the naming of the triangles and actually using the triangles themselves because you can see what goes with what. I know A goes with N, I know B goes with the S, and I know L goes with the O. So I could say angle A is congruent to angle N.
And we're allowing you to use just the vertex because there is only one angle at that vertex.
I can also say that angle B is congruent to angle S. And my last angle, angle L, is congruent to angle O. Now, using the naming of the triangles is very helpful, especially when it comes to naming the sides. So, for example, we'll start off with the line segment AB. And all I am going to do is I'm going to find the match of AB on the other name of the triangle. So I've got pink and green, so I'm going to use pink and green on the other, so NS. So line segment AB is congruent to line segment NS. My next line segment is line segment BL. Looking for my match on my other name, and I find that the match is going to be line segment SO. And my last line segment is line segment AL, and I find the match would have me writing AL is congruent to line segment NO.
And at that point, we've written actually 7 congruency statements. That would be the conclusion of this problem. There's nothing else we could talk about. We talked about the shapes themselves and then all of the parts that make up the shape, the 3 angles and the 3 sides.
Okay, what do you think, Miss Weichel? Let's give them a chance to try this one on their own.
Yep, we're going to go ahead and have you pause the video and do the same thing we did in the previous problem. Write down all the congruency statements that you are able to make from these 2 triangles.
Good luck. I know you'll do great.
All right, hopefully this is what you guys came up with. We have triangle A, B, C. And if you look over here, we have our A, B, and C. Not the right color. And then you just had to make sure you had the corresponding part. So between the 13 and the 15, you should have had Z. So Z went first. Between the 13 and 11 was B, so between 13 and 11 was X. And then lastly, C was between 15 and 11, 15 and 11 right here.
So if any of you put triangle ABC and then just assumed that the other triangle would be XYZ, this is a good example of you really can't assume much when it comes to geometry. You have to go based on the facts and the given information.
And then from the triangle congruency statement, as we did in the prior problem, you should have been able to make your 3 congruency statements about the angles and the 3 congruency statements about the sides. So if you have any questions about that, please reach out to one of us or to your teacher.
All right, I think we have another vocabulary word.
Okay, just to wrap up this lesson is called rigid transformation. So what we're going to be doing is we're going to be taking one shape and moving it onto another one. That is called a transformation just in general. It's when you take one figure and move it onto another. The pre-image is going to be the before image. It's what you start with. So sometimes you'll just get one shape from us and we'll say, okay, move it onto, or make the new one. So the shape you're moving is the pre-image. The image that it moves to, or the after image, is just called the image. And then specifically, rigid transformations are a transformation or series of transformations that preserve size and shape. So remember, preserve means it keeps the same size and shape. So we're dealing with pre-image and image that are always congruent to each other in this particular chapter.
So a couple of your vocabulary words just right here on this page: transformations, pre-image, image, rigid transformations, and the word preserve. So you can go ahead and add those to your vocabulary section right now.
All right, I believe that is it. Hopefully you guys feel confident in what congruent means and identifying congruent pieces.
I hope so.
I hope so.
You think so? Hey, Mrs. Weigel.
What's up, Mrs. Nats?
What do you call people who like tractors?
What?
Protractors.
Ah, ha, ha. All right, we will talk to you in the next segment of high school geometry. Thanks for joining us.
Bye.